Welcome to another episode of Creo Parametric for SolidWorks users. This is part one of a series on surfacing. In this video, we are going to start off with a few different slides. I'm going to talk about the three different paradigms for surfacing in Creo Parametric: technical surfacing, freeform surfacing, and subdivisional surfacing. Then I'll go through the equivalence between SolidWorks commands and Creo Parametric commands. Then I'll jump into a demonstration to show you some basic technical surfacing tools. For the first main paradigm that you have in Creo Parametric, there's the standard technical or parametric surfacing. And this is where you primarily use different curves, sketches, and edges from geometry as boundaries and trajectories for different features. And those can include your basic features like extrude, revolve, sweep, and blend. And also there are advanced features like the swept blend, the helical sweep, and the rotational blend. One big difference between Creo Parametric and SolidWorks is that in SolidWorks, you have separate commands for an extruded boss, an extruded cut, and an extruded surface, but in Creo Parametric, they're all within the same command. Also, on the parametric side of surfacing, there are some specific commands like fill and boundary blend. I'll show both of those in the demonstration. And once you've created a bunch of different surfaces, then you can edit them. And there are a variety of commands like trim, merge, extend, offset, warp, divide surface, and unify surfaces. The second kind of paradigm for surfacing that you have in Creo Parametric is called freeform surfacing. And this is through the style feature in the interface. The style feature uses a module called ISDX, which stands for the Interactive Surface Design Extension. And the style feature is referred to as a super feature because it can contain multiple different curves and surfaces. And the difference between ISDX or style features and regular parametric surfacing is that you're more designing by feel. You're creating curves and you're moving them around in three-dimensional space. You're creating surfaces through those different curves. And when you make changes to those curves, you can see the surfaces update in real time. And one of the advantages of using the style feature is that you can create continuity up to G3. The third paradigm for surfacing in Creo Parametric is subdivisional surfacing, and this is through the freestyle feature. This is very similar to 3D Sculptor, which was recently released by Dassault. With freestyle surfacing, what you're doing is you're starting off with a primitive, and those primitives are usually spheres, cylinders, tori, or cubes. And then you're doing different operations to that primitive. It's going to have a control mesh around it, and you can grab that control mesh and you can drag it, you can rotate it, and you can scale it. Plus, you can do things in the mesh like add splits to faces and edges. You can increase the crease of your different edges in the geometry. You can extrude faces, you can align them and planarize them, and also you can connect different faces together. And you also have mirror and rotational patterns. We'll cover subdivisional surfacing in another video. Now let's talk about the commands that you may be familiar with in SolidWorks and what they're called in Creo Parametric. And I don't have extrude and revolve in here because those commands are the same. But in SolidWorks, you have a loft or a lofted surface, and that's mainly the blend command in Creo Parametric. With lofted surface, there is an option for using a centerline curve. If you're doing a loft in SolidWorks with a centerline curve, that's more akin to a swept blend in Creo Parametric. A boundary surface in SolidWorks is called a boundary blend in Creo. And now here's a little weird thing. A planar surface in SolidWorks is a fill surface in Creo Parametric, and in SolidWorks, where you can pick a bunch of edges from geometry to create a planar surface, in Creo Parametric, you have to use a sketch as the input. You also have a fill surface in SolidWorks, but you can create the equivalent of a fill surface in SolidWorks using the style surface or the end-sided surface in Creo Parametric. And the end-sided surface by default is hidden in the interface. There's an option that you can use in order to turn on its display. A radiate or radiated surface in SolidWorks is created through an editing command in Creo Parametric called the extend command, and some other different editing commands that you have in Creo Parametric. Copy and paste is used for the untrim or untrim surface command in SolidWorks. Where you knit or create a knit surface in SolidWorks, that is from the merge command in Creo Parametric. And be aware that's the merge command from the editing group. There is another command called merge inheritance that's used for data sharing. To replace a face in SolidWorks, that's from the offset command with the replace option in Creo. You have the freeform command in SolidWorks. In Creo Parametric, that's through the sculpt option in the warp command. And as I mentioned in SolidWorks, or rather from Dassault, you have 3D Sculptor, which is a separate user interface. Well, that is the freestyle feature in Creo Parametric. All right, now that we have gone through the different commands, let's jump over to the demonstration. Here I am in a part model in Creo Parametric. I have created a bunch of different curves and sketches in order to show you some of the basic technical surfacing commands. First, let's start off with a fill surface. A fill surface allows you to create a flat planar surface, and it takes a sketch as the input. So for example, I can choose the fill command. This is the interface. Here's where you can select the sketch, either from the main part of the dashboard or the references tab. And I'll just select a sketch here, and it fills it in. There's a properties tab if you want to change the name of the feature, but that's pretty much all there is to it. You hit the check mark and the feature is created. To unclutter the screen, I'm going to hide a bunch of my surfaces as I create them. I can get to the hide command by clicking on a feature and then using the hide command in the mini toolbar. Actually, I accidentally hid my sketch. Let me make sure that my sketch is visible because I'm going to need it later on. All right, for the next one, let's take a look at the extrude command. So for extrude, I can select it and then select a sketch. And by default, this is creating solid geometry, but I can turn this into a surface. If I hold down the right mouse button from the mini toolbar, here we have the option for creating this as a surface. If you leave your mouse over the icon, you'll get the tooltip. But instead of using the mini toolbar, if you're a new user, you might be more comfortable starting off by using the dashboard. Click on the surface option. Let me rotate this, and so right now you can see through it. If you go to the options tab, you can choose capped ends so that it will look like an enclosed volume, but it'll really be closed off. All right, let me select this extrude, and I'm going to hide it as well and go back to my sketch and make it visible for what I will show you next. I'm going to create a Revolve feature. You can select a sketch, and then from the mini toolbar, here is the Revolve command. So that's a little easier way to go rather than starting off looking for the command in the ribbon. And this particular sketch already had an internal center line, an axis of revolution designated, but you could choose something other located in your model, like a vertical edge of another sketch, or I could use a straight edge or an axis in the model as the axis of revolution. But similarly, right now, this is being generated as a solid feature. If I right mouse click and hold from the mini toolbar, I can choose to generate this as a surface. And in this case, I can use the drag handle and make it less than 360 degrees. Similarly, just like with the extrude, I can choose to cap the ends so that it'll be an enclosed volume, but it just won't have any interior solid material. Once again, let me hide this to unclutter the screen and bring my first sketch back. For the next one that we're going to take a look at, let's create a blend. And a blend is known as a loft in SolidWorks. The blend command is a little less frequently used. That's why it appears in the overflow menu, but be aware that you can rearrange the ribbon. If you use this command a lot, you could promote it up to the main part of the ribbon. But anyhow, I will create a blend. And from the sections tab on the interface, we can choose to sketch our sections within this feature, or you can select some pre-existing sections. And since I already created a bunch of different sections, I can go about selecting them. So I will select this one, and you'll notice that we have one vertex which has a circle on it. There's an arrow. The direction that the arrow points doesn't matter. It's just to like draw your eye's attention. This is like the different connectors you have in a loft feature in SolidWorks. So that's good for my first section. It has 4 vertices. I'll click the Add button and then select this one over here, and we can see where the starting point is, which vertex has the white circle and the arrow on it. That looks good. Let me add another section, and I'll pick this one over here. You can see how the preview is updating. Right now, it is interpolating between the different sections. Before I select the 4th section, I'm going to show you some of the other different options. So here we can change from having smooth blended surfaces to having a straight blend, where it'll just put straight lines from one vertex to another. If I go back to the Sections tab in here, actually, let me go back to Options and change this to Smooth. Now we have the Tangency tab, so you can control the boundary conditions at the beginning and the end. If I had adjoining geometry, I could choose if I wanted to be tangent or normal to that adjoining geometry. But I don't have that in this case. Now let's talk about another difference between SolidWorks and Creo Parametric. And this is one area where SolidWorks is a little bit more flexible. Here we have the number of vertices per section. In Creo Parametric, the sections are required to have the same number of vertices except for the first or last section, which can be a single point. So let me try to add in another section, and I'll try to add this circle. And for the number of vertices, it has the number 2. The way that Creo Parametric defines circles and cylindrical surfaces is by breaking them up into 2 halves. So right now, with an unequal number of vertices in the 4th section, if I hit the check mark and try to create this, it's going to fail. So I'm just going to cancel out of there and cancel out of the tool. So let me show you one thing I can do for the sketch in order to make it usable. I'm going to select it and then edit definition, and let me zoom in over here. I'm going to use a couple center lines to break this up. Let me throw in a center line here and a center line here, and let me change this dimension to 45. And then now that I have the vertices in here, I can use the divide command to break this up into a bunch of segments. And now I will hit the check mark. Let's try creating that blend once more. I'll go to the Shapes Overflow and then choose Blend and select one section. And oops, I meant to select instead of sketching. Yes, I will remove everything. Let's select our first section here, and then I can go back to the Add button. I was trying to see if I had right mouse button functionality to get to the Add button. Let's add in another one, and then add in one more time and select this one over here. In this particular case, you can see that we're getting a bit of twisting between the different vertices, so I can grab that little drag handle and change the vertices so that they now line up. And in this case here, it's like, I think this will look a little better if it is straight instead of smooth. So that's good. I will hit the check mark, and there we have our blend created. And once again, let me select this, and I'm going to, oops, I accidentally created that as a solid feature. Let me edit definition. And if I want to create that as a surface, once again, I will just hit the surface button. Then I can hit the check mark. Now this is a non-solid feature. Now that I have my surface created, I can hide it. And let's see, for the 4th feature to show you inside of here, let's take a look at creating a sweep. And this is another difference compared to SolidWorks. And just to unclutter my screen, I'm going to turn off the display of a few of the sketches that I am no longer going to need in this demonstration. Let's say I want to create a sweep. Here is the command, and we're going to select our trajectory. So the trajectory has to exist beforehand. And you can see that we have a little pink arrow indicating the start of the trajectory. In SolidWorks, you create your trajectory and your section first, and then you create the sweep command. In Creo Parametric, you have to create the sketch for the sweep within the feature itself. So for example, for the sketch, I can't just pick this entity to use. I can use my right mouse button and this icon in order to go into sketch mode. There's also a button within here to get into Sketcher. And I'm going to create, let's use a center rectangle. And what you'll notice is when I start it here, it'll even snap to the existing sketch that was in the model, but I just can't use the original sketch. So I will hit the check mark. Right now, this is being generated as a solid feature. Again, a big difference between SolidWorks and Creo Parametric is that in Creo, you just have a single tool and you just toggle whether it's going to add material, remove material, or create a non-solid feature in the model. And from the Options tab, you can cap the ends if you so desire. Let me hit the check mark in order to complete that one. And for the last one, to show you that previous sketch that I used for the trajectory was just a sketch itself, just a bunch of straight lines in a plane. But your trajectory is not limited to 2D. You can use 3D trajectories, and this particular one is 3D. I created it using a style feature. Okay, I will start off by selecting my sketch, and then from the mini toolbar, this is where I can get to the sweep command, and I will choose it. And then from here, I can right mouse click and hold in order to get to the sketch for my section. And then I can right click to make a circle, and I'll just drag it and make a small diameter circle. Then I'll use my right mouse button to get to the check mark to complete out of the feature. Now you can see the 3D sweep that we would end up generating here. Oh yeah, once again, I want to generate this as a non-solid surface feature. So there you can see it is hollow on the inside. And I'll hit the check mark. And so there we have a three-dimensional sweep in this particular case. And there's a lot of different variety with creating sweeps in Creo Parametric. I have like a 4-part series. I recommend that you check it out. Okay, so those were some of the basic commands. I'm going to hop over to a different model to show you a boundary blend, what is called a boundary surface inside of SolidWorks. And with a boundary blend, what you're going to do is you're going to select geometry and curves in 1 or 2 directions in order to form your surface. To create a boundary blend, here is the command in the ribbon. And right now, the collector for curves in the first direction is active. I'm going to start off by selecting this edge in the model. And it's got a portion of the edge. I want it to also include this portion over here. And so now I'm going to hold down the Shift key. And the Shift key allows me to add that other additional edge to my first curve. So it is the Shift key in order to build up a surface. Now I'm going to hold down the Control key and select this other curve in the model, which was from ISDX or a style feature. So that's good for my second curve in the first direction. Now I'll hold down the Control key to select a third curve in the first direction, but it didn't get the whole thing that I wanted. So once again, I'm going to hold down the Shift key to add a segment to my third curve in the first direction. So that's good, except it's not exactly lining up with the edges in the part. So I want to add some curves in the second direction. I can either click in here to activate my second direction collector, or click in here to do the same, or I can right mouse click and hold, and from the pop-up menu I can choose second direction curves. And in this case, I'll select an edge in the model. Just got a portion of the edge. So once again, I'll hold down the Shift key. And so now I've got that edge. I still don't have a preview because we don't have enough inputs in the second direction. For the second curve in the second direction, I'm going to hold down the Control key and select this curve here. And so now we can see a much better preview. Let's hold down the control key once more and grab another curve in the model. And for the last curve in the second direction, I'm going to hold down the control key to select another one. And it didn't get the whole portion, so I need to hold down the shift key to build that up. And there's a lot of flexibility with the control and the shift key for getting the exact boundaries that you want, but this is an area that can be a little confusing for new users. One other thing to note is that on the four boundaries, there's a circle, and you can right-click on the circle to change the boundary condition. So for example, maybe I want it to be tangent to the surface at that side, and maybe also on the back side I can do that. The other options that you have are normal and curvature, but let's choose tangent. And it adjusted the shape in the preview. When I hit the middle mouse button, it'll make sure that the surface is going through my different references. So that's how I created a surface using a boundary blend. So there you have it, some of the different ways of performing surfacing in Creo Parametric.